we're going to start a third project using all the same techniques, but it is a different sketch altogether. We're going to use this piece of reticulated textured metal. We're going to use this Holley agate, and it's going to get a Yogo sapphire, a little Yogo sapphire from Montana. So let's see how we're going to start that. I'm going to have to think about that one for a minute. Okay, but we do know the first thing we do is start by making a bezel. We talked before about looking against a white card to get things in silhouette. So I put the agate in the bezel and I looked at it, and then I looked down on it, and I'm going to show you that if I had this down, I was looking down, I could see against the white card, I could see some of the gaps in where the bezel doesn't quite fit the stone, and that's how I could make my adjustments. So again, using your white card in a little bit different manner can help you figure that out. Okay, this time I am going to solder using yet another method. Since I have extra material, extra sheet material, I can use it as a little handle for my third arm to hold, and I don't have to put it on the cinder block in this way, and I don't have to put it on a screen, and I can still heat the piece from underneath the sheet metal. Dry off the flux, it's going to bubble, and then if your sheet was too thin, this might not work because it might sag and overheat easily. It's a fairly stout piece of sheet material, so if I control my heat, I'm not too worried about it. Pick up your solder, stick it right on. I'm just going to use 2 pieces because I've got a pretty small bezel. Put them where you can see them. How about that? Well, that's a really big piece of solder over there. Make sure it's against your base and your bezel so you are bridging the gap, bridging the seam. Okay, got 2 pieces of solder there. Now just heat from underneath. Keep everything moving. Now the third arm is going to, oops, see, it's already going. It's going to sink a little bit of your heat. So make sure and compensate by getting a little extra heat on that side of things. And toward the back where there's no solder, you want to draw the solder from the front where you can see it to the back. Looks like it's already flowed. Just make sure you've got good glassy solder all around. I think that was all it took. Now I'm going to, before I take it completely away, I'm going to turn this around and make sure that seam is complete. And okay, I see one little corner back here that was near the tweezers that did not flow. So let's just I'm going to grab an extra little bit of flux and put it right there, and then I'm just going to reheat it. That was where this tweezer was, and that was a little bit cooler on the piece and didn't allow that even heating we like. So I'm just going to reflow it. I should be able to draw the solder right to the front corner there once I reheat the whole thing, and then just watch it and see what happens. Draw it over, come on. Yes, and yep. Okay, we got it. So before you unset your whole solder station, check your seam, and then you don't have to be going back in and resetting everything up. Protecting my fingers, supporting the work. There's one more side to go. Then we have some decisions to make. This one's going to be a little different. Not 100% clear on my thinking here. So here is our beautiful Holley agate. It's an Oregon agate from Sweet Home area. Really unusual color. Very typical of Holley, but unusual in terms of the agate world. And I have a design, and it's very vague. I'm not sure what this design is really going to look like. But I do know I want to use this piece of textured reticulation and this holly agate and our regular split shank material. And let's take a look a little bit down on it, see if we can see. Do I like this piece of reticulation thickness? It's a little thin unless I use it as an inset, which I'm not sure I want to do, although I could do it the same as I did this ring, make a V split and then put the reticulation in it, and that would be dramatic. And then maybe have the split shank come around the other side, like we did with this piece here. That would come around, and that would be interesting. So we could do something different with this piece altogether. In terms of the side view coming, finger view coming around the finger, the other rings that we just did were round on the finger, right? We don't have to do that. We could use the flatness of this reticulated sheet. We could put the rims on the bottom to give it the perceived thickness we like. So instead of being a thin sheet, we would add a couple millimeters and thicken it up, okay? And then use that as the top of the whole piece, or most of it, as the top of the ring. Put the agate to the one side, and then do a ring shank that's not round at all, but that maybe the ring shank comes up down in a U shape, kind of like this. That could be interesting. Now, it might be that this is offset, so if you have your reticulated piece and then your agate piece and some thickness there, and then this comes up around like this. So it's still round on the bottom, but you've done and you could put some curve here, but you created what, like a top that has shoulders to it instead of round. So that's using, again, our same techniques of a shank and a split and a bend and soldering, but we're going to use a completely different ring shape with a shouldered top and a U-shape shank. How about that? Let's give it a try. Ooh. Well, see, that's interesting because that takes then accentuates our shape. Let's put the agate in the center of the ring as we look at the finger. And do we want it that way or do we want it this way? No, I definitely want it horizontal. I think we're going to use most of this reticulated piece across the finger in some fashion. This will come in and intersect in some fashion. So I'm going to figure out where I want this agate to intersect so that I accommodate. I like this contour, so maybe I don't want to mess with that. Maybe I'll have it intersect from this side. Okay, I have changed direction entirely here and realized I wanted to create more contrast with the textured piece. And I'm going to show you kind of what came to me. I like the whole concept of this U-shaped shank and the curving, slightly curving top with the shoulders and the cabochon. But now I've got some sterling silver here, and I'm making a frame just like this, and it's going to curve around here. I'm going to overlay it so I have this interesting contrast of the frame, which will be dark oxidized sterling, and then I have the reticulation, and then I'm going to cut in, and this piece will fit in and be kind of lower level, not up on top like this, it'll sit down, but it'll tuck right in there, and I think I'll have the point hit this piece of silver, and then this piece will come and meet this point. So I'll have this very interesting top piece, almost like a little shield, that will then connect to the ring shank, which will be, I'm not even sure it'll have to split. We'll see how that goes. Again, we just have to make these decisions as they come to us. This is very interesting. This one has got me going. Okay, so you might be wondering how we're going to get this to be pointy up here. On this side over here, I cut it, put like a 45-degree cut almost all the way through, bent it, and then soldered it shut. Now this is really too much of an angle. If I try to cut it and then bend it all the way back around at that sharp of an angle, it'll just break the material. So what you can do is cut and then just make a joint that meets like this. Okay, you just cut it, angle your ends, and make a joint that meets at an angle like that. And that probably is what we'll do. But I might start by doing the cut and bend, just so I have it in the right place. And you could throw a little solder on there and then do a little more bending, so that's another way to do it. Let's see, I'm going to try it that way. I'm going to cut at an angle. Don't go all the way through though if you don't need to. I'm going to cut back and I'm going to give it another cut. Meet it, make a nice V-shape cut in this material. Not going all the way through though, there. Then, now this could just break in two because it just could, but I'm going to give it a bend to get it going in the right direction. Yeah, I like it, I like it. I can feel and I can see it's stressing there, but I'm going to keep bending a little bit. Okay, now I meet resistance because there's no more space in the cut. The 45-degree or approximately that I cut is already, it's met each other on both sides, so it won't go any further. So I can cut it again, and then I can keep going. But again, it's going to break, so, because it'll be so stressed back there. But let's see. It still gives us a nice indication of what we're trying to achieve. I can bend it a little more. That's pretty good. Let's look at our drawing. Well, this is going to have to come at a much steeper angle. Let's see how it's looking here. Oh yes, I like the way it overlaps and has that nice contrast with the sort of structural architecture of our frame and the rough-hewn nature of the reticulation. That's nice. Well, maybe we don't want that pointy there. Maybe this is a good angle. Let's look at that. Okay, I'm feeling it right now. I'm going to make another cut. Instead of making this a point, let's work with our material. I'm going to make it sort of like a truncated pointy shape. I'm going to make another 45 here. Yes, I like this. Don't go all the way through. Let's see what we can do here. Okay. Give that a little more cut right there. Okay, so now we've cut an angle in here. I'm going to take a plier. I've got a flat plier here. I don't know if you can see this. Okay, got a flat needle nose, and I'm going to just carefully bend that. Ooh, I like that shape. Okay, but we also probably want it to have a bit of a curve, and we know we're going to put this in here somewhere, and it needs to come over and meet up. And probably we're not going to need all this material. So let's cut that off so we can put a curve in here nicely. and see how that goes. Okay, I'm just going to cut it off here. Okay, I can just kind of bend this. There. Okay. Now, let's put some curve in here. I'm going to use 2 pair of pliers, I think, because this is fairly stiff. Okay. I like that shape. Let's see, maybe a little bit more curve. Oh, that's too stiff. Let's use another pair of pliers here. Okay. Okay. Now, if we take that shape, which is a brand new concept, and take this shape here, stick it on top in some manner. I want to make room for that sapphire right in there, probably. This is going to come in here. Something like that. Okay, this actually does need to come out a little further, I think. More like that. Oops, come back here. Oh yeah, so we get more of a framework there. Oh, I like how that, I like the way that touches there, there. And then somehow we get this piece to come in. It's got kind of a long side and a short side. No, I think the long side needs to be over there. Okay. Well, it's going to be wild and crazy, but I think it's going to be fun. So I guess the next step is to solder these 2 joints on the frame so they stay where I want them. And then it might even be then time to solder the reticulation on and then fit this to all of that. That's the ticket. Okay, let's do it that way. On this side over here, I cut it, put like a 45-degree cut almost all the way through, bent it, and then soldered it shut. Now this is really too much of an angle. If I try to cut it and then bend it all the way back around at that sharp of an angle, it'll just break the material. So what you can do is cut and then just make a joint that meets like this. Okay, you just cut it, angle your ends, and make a joint that meets at an angle. But I might start by doing the cut and bend, just so I have it in the right place. And you could throw a little solder on there and then do a little more bending, so that's another way to do it. Let's see, I'm going to try it. I'm going to cut back and I'm going to give it another cut. Meet it, make a nice V-shape cut in this material. Now this could just break in two because it just could, but I'm going to give it a bend to get it going in the right direction. Yeah, I like it, I like it. I can feel and I can see it's stressing there, but I'm going to keep bending a little bit. Okay, now I meet resistance because there's no more space in the cut. The 45-degree or approximately that I cut is already, it's met each other on both sides, so it won't go any further. So I can cut it again, and then I can keep going. Still gives us a nice indication of what we're trying to achieve. I can bend it a little more. That's pretty good. Let's look at our drawing. Well, this is going to have to come at a much steeper angle. Sort of structural architecture of our frame and the rough-hewn nature of the reticulation. That's nice. Okay, I'm feeling it right now. I'm going to make another cut. Instead of making this a point, let's work with our material. I'm going to make it sort of like a truncated pointy shape. I'm going to make another 45 here. Yes, I like this. Okay. Give that a little more cut right there. Okay, so now we've cut an angle in here. I'm going to take a plier. I've got a flat plier here. I don't know if you can see this. Okay. Got a flat needle nose, and I'm going to just carefully bend that. Ooh, I like that shape. Okay. But we also probably want it to have a bit of a curve. And we know we're going to put this in here somewhere, and it needs to come over and meet up. And probably we're not going to need all this material. So let's cut that off so we can put a curve in here nicely. Okay, I can just kind of bend this. There. Okay. Now, let's put some curve in here. I'm going to use 2 pair of pliers, I think, because this is fairly stiff. Okay. I like that shape. Oh, I like how that, I like the way that touches there, there. Come in. It's got kind of a long side and a short side. No, I think the long side needs to be over there. Okay. Well, it's going to be wild and crazy, but I think it's going to be fun. So I guess the next step is to solder these 2 joints on the frame. It might even be then time to solder the reticulation on and then fit this to all of that. That's the ticket. Okay, let's do it that way. Okay, I took this frame that I just soldered on and I sanded it into a nice satin finish because it's not going to be easy to finish that up after we have it soldered on. And the back side of this has been kicking around for years, so we know there's oxides and stuff on that. So I sanded up some of the spots where we're going to have contact with the solder so we have a better chance of good solder joints. Okay. This piece doesn't have real good contact. At the same time, I'm not going to need it because when I cut this out and put the agate in, I'm going to have great contact. So let's just leave it where it is because I do like the look of it. Okay. We probably need one more piece on the back side over here. Okay, great. Let's heat it up, do our usual thing. Okay, keep it moving, coming up to temperature. Reticulated metal is interesting in its own right. Okay, it's sticking up. I want better contact. Okay, come on. I'm using my solder pick to push it down a little bit to get better contact. There, now we're flowing. But reticulation is odd. You prepare reticulation by drawing copper to the surface and pickling it off and leaving fine silver behind. And there we go. Okay. And then you go through doing that a bunch of times, and then you go back in and you literally have created a high melting temperature skin on your silver. And then over here, oh, we missed a piece here. And then you go back in and try to literally melt the inside without melting the outside of the sheet. It's real interesting. So I am going to take a wooden form. It's kind of got a little depression carved into it here. And I'm going to, I've got a really big bulber, excuse me, I've got a really big dapping tool here. And I'm going to put it right there, and then I'm going to hit it. You can hit it with something bigger. I'm just going to use not a very big hammer because it's silver. It's going to move. See if we get it to move like I want. Oh, okay, it is curving. It's curving ever so slightly. Let's see. Maybe we want a different ball. Maybe not quite so big. Oh, yeah. Okay, now I've got more curve. Okay, now I've got some contour, a little bit of a curve here, and that's going to fit the finger better. We may do a little bit more of that. I have been working on this, and I've got a pretty good cutout and fit for this bezel into this top piece, and I like it. I'm going to remove the agate, and I'm going to solder it right in. I'm not going to use any more hard solder. That really brought the copper out in this reticulation, which isn't a problem. We'll get rid of that later. We'll pickle it some more and stuff. But I don't want to do that anymore. So I'm going to solder from the back side here. I'm going to put my medium solder in strategic places there. And then that'll look pretty cool from the back too, won't it? This is a soft piece. The one behind I've been using is the hard piece. This does not have any give. This is soft. And so you can kind of crumble it, you can compress it, you can smush things into it, and it helps you a lot with positioning. Next, now I can keep my solder where I want it. I'm going to flex my joints, and then we'll use some medium solder and get this all put together. The other nice benefit of the charcoal block in general is that it does reduce fire scale because it reduces oxidation. It's an oxygen reducing atmosphere. So if you have, you'll find that the piece that's facing the charcoal block will have very little fire scale, if any, on it. Just picking up some solder. I have a big seam right back here. Okay, well really it's just those 3 places. So I'm just going to do my overall heating. Oops, that solder doesn't want to be in the right place. It needs to bridge that seam or it's not going to go where you want it to. If the solder doesn't touch both sides of the seam, then why would it solder the seam? So that's why you put it between in the seam, and then oops, it didn't go to the right place. Now I didn't get enough heat over to the right, and so the solder jumped to the left where the heat was. Now I have to push it. Now it's filling, and this one filled fine, and then this one, oh that's right, I'm using medium solder. It went so fast. Since this one wanted to migrate where I didn't want it, I'm going to put a little more solder there so that I don't have to come back and fill it later, because it looks like it didn't fill all the way up the edge of the bezel there. So now let's get this the heat more to the right and to the front. See if we can pull that solder into place. There, that's better. I saw it pull right down into that seam. Boy, that melted way faster than the hard solder. I wasn't ready. Gee. But you see the heat not being, and I used too hot of a flame. I can see that now. The heat wasn't where I wanted it to be, and so you can see all this solder that migrated off to the left, because that's where my heat was. I wasn't focusing enough on the right, so it migrated this way, didn't fill my seam, which is okay, but that means you had to go back and add more solder, get your heat in the right place, and then I've got a bunch of solder to clean up. I don't want that solder there. It'll discolor the piece won't look right. So just wasn't paying attention. It's going to be an interesting ring. Okay, pickle time. And I changed my mind on this ring shank. I decided with this large top, it needed some more width to the ring. And I decided to make it's not a split shank in the same way that we've been doing. But it is a double shank, but I put a spacer in the back. So it gives it a whole different look. Now, I happen to have the right size of material to just cut two pieces and do that, but you could take the same material we've been using for our split shank and just split it all the way down, and suddenly you have two pieces. You just finish off your edges and create some spacer pieces, and now you have a whole different style of ring shank. I think this is going to give it a super interesting look. It's very sculptural, the whole thing. Now it's going to move around a little bit just because that's what things do, and with the flux it pushes it, but you can push it right back into shape. You want that to be a good point of contact there. Don't let there be a gap. I've got a larger area to go back and forth on, so I'm going to give it a little more flame. Cover my area well. Okay. Heat back and forth. This is a way to get a wider ring shank without being so thick and heavy, and yet it looks completely interesting and contemporary. Okay, you're all done there. I've got the ring shank out of the pickle, and I like how it looks. I'm just sanding it on some emery to smooth it up, and I'll just do that for a while and flip it over. When I put this together, I cut equal lengths of the silver, and then I measured with my divider so that I didn't have to do any math, of course, and I just measured and marked on both pieces where I wanted to put the cross supports. So that is basically centered, and I've made some decisions here. I like my shape. I'm going to trim this frame a little bit where I've put the Sharpie. I'm going to trim it here, make this kind of flare out a hair, look like more of a fan, so that's not as clunky there. And I thought that the curve up here was a little bulky, and I'm going to take that down and thin it out. And I want the frame there to accent that structural frame to accent this really organic looking silver, but I don't want it to overtake it and be too dominant. Most likely I would just come in with a file and hold the piece, get that out of the way, and just brace your work and file off what you don't want to be there. You could use a grinding wheel or something, but file is easy to see your results, and you can stay in control of it. Don't file off something you don't want to file off. Like I like the way these little things protrude. I don't want to bump those with my file, so do watch that. Looks like I'm getting a slope here. I want this to be more perpendicular, so I need to file on the bottom side of that. So just work all the details. Flipping it around might help too. Work all the details that you can see and refine your shapes. Then after I do that for a while, I'm going to come here and look at how this ring shank, this new idea, is going to fit. So I think I liked the idea that this would come up here like this and be very structural, right? And that's kind of interesting. And then on the other side, I would think I'm going to maybe separate these a hair and have them come up on either side of this and be like a little design element. You'll see two little squares there. That'll be kind of interesting. So we need to make this ring shank into a U shape. And like our drawing, we're going to do kind of a U shape, something like that, something like this one. So, whatever you do, be symmetrical here in terms of the bending, because without being able to later put it on a round mandrel, which we cannot do, because of the U-ness of it, we have to be super careful that this stays symmetrical in our bending, because we can't go in and correct it by hammering it onto a ring shank. So I'll start, I like my forming pliers for this. Let's see. Okay, so you have to work from one side and then the other side because they're going to bend independently. I guess we can put it right next to the support. And put a bend in there. Go over here. Put a bend in there. Go turn it around. And this is not a ring shank I've actually made before, so we're just doing it for the first time together. How about that? I've done cast versions of this, and I like this way of doing a wide shank so that you really get the width without all the bulk and all the weight. And when you're working in precious metals, sometimes that is a benefit. Let's see, I have to flip it around. Take it slow. You can always unbend it, but that just adds more tool marks and stuff as we go along. Okay, here's where we are. That's pretty good, but well, this is all really flat across the bottom, and that's not how I want. I want to have some shape to it, so let's put a little shape in there. That'll also bring the sides up a little bit. That's a little bit of shape. Turn it around, do the other side. Oh, that's a nicer, little bit more comfortable looking, a little more graceful shape. Good curve on the bottom. Maybe a little more over here. Looks good on that side, and this side needs, for symmetry, let's pull this one in here. Okay, look at that. We have a cool looking ring shank. It's got some tool marks, but we'll take care of that. That's kind of nice looking. Okay, so the difference between, you know, an okay piece and a really nice piece isn't necessarily the design work at all. It's just how it's executed and the finish and looking at the details and seeing that there was thought put into stuff and that there's no gouges and scrapes and things that just say, ah, they just didn't pay too much attention or didn't know what they were doing. Okay, I'm good with that. I'm good with this. I'm going to set this up to solder it. Yes, I like that. I like it coming slightly in from the corners. I like that. Wow, yeah, this looks really great. Okay, so to solder this, actually, we have one more adjustment. I can see we have, actually, there's a little bit of a, these two arms need a hair of an angle that way, and they'll fit better, and I'll have a better solder seam. They're too flat, and there's a gap, wedgy gap, to create a slope, so the point of contact is going to be better, and I won't have a wedgy gap at the inside of this ring. I think we have much nicer seams now. That was just a little thing, but I would have had a little gap back there, and that, again, is this, if someone turns it over and looks, there's a little gap. It's just not quite as finished. Didn't take much to make it better. What it took was some powers of observation, a little analysis, and application of your basic techniques. So to get this soldered, I think, okay, literally it stands up by itself. That's good. We're going to use medium solder because we don't want any of our hard solder seams to fall apart. You could do it standing up like that. We could turn it over, and that might even be better, is if we embed the top piece into a charcoal block and then set this on it there like that, and then come at it and just let gravity hold it in place. I'm pretty confident of that. Okay, as you have noticed, there are many ways to do any given project. And you could hold this in a third hand, 2 third hands, and bring it together. You could solder it with the shank down and the top up. You can do it this way. If you were worried about the security or the balance, you might take a third hand in and come in and anchor this down. You can really do things many, many ways. Whatever works for you and makes you confident in what you're doing. What I do want to make sure is that I am equidistant. This ring shank is the equidistant from the corners. Make sure I've got that. That seems okay to me. So that'll just give it a little bit of a weight there. So it'll be less inclined to slide when we place our solder. Basically, I'll need 4 pieces of solder, but cut always a couple extra because they get dropped, they flow the wrong direction. So don't be stingy with solder. Be prepared, otherwise you end up having to stop in the middle and cut some more, and that's kind of dumb. Okay, or some people cut up like little containers full of one type of solder or another, and then they have it. You don't have to worry. Okay, I dropped a little piece of solder right inside, and I don't want it in there. And you say, well, it's not going to hurt anything. It'll just be in the wrong place. You're right. It'll look like crap. And so we don't want that. So we can get a little closer here. We can see what's going on. Okay. And so, yeah, if you drop a piece of solder and it's going to melt in the wrong place, that isn't going to look good. So get it out of there and get it in the right place. Okay, I've got 4 nice pieces of solder. I love soldering. It's really fun, and it's a challenge. You know, you got to make it work. And so if you do it right, then it works and it's satisfying. If you do it wrong, well, it's hard. But you can always improve it. Oops, that went up, that went down. Good, we got it in the right place. That went, that's good. You're going fast, got a big flame, that's why. Oops, that one went in the wrong place. We'll have to add to that. This one, I'm coming there. And I like it. Now, we need to add some to the place where it didn't flow. Apparently I don't have a great seam there, and that's on me. So I didn't notice that angled piece was so a little bit not fit well. Okay, I think we got 4 really good seams. Bada bing. I really enjoy soldering. I love the process. Good soldering comes down to just preparing. It's preparation. Get your solder cut, make your seams fit, keep them clean. You know, do a soldering setup that you can stay in control of, the positioning and the flame and all that. And it's really satisfying. Now, here's our 3 rings. We started with just bits and pieces and stock and some pretty minimal sketches, and we have 3 really interesting things going on here. Very, very divergent, yet they all started out from a similar place. And all we're doing is sawing and soldering. So, and thinking. That's the fun part though. So, can't wait to see how these turn out. I'm just going to continue on all of them simultaneously, just detailing them. Smoothing surfaces, sanding, filing, getting rid of divots. You don't need to see me do all that. It's just tedious work, but it's kind of fun, and it's where the real, like I say, the fit and the finish comes in. And that's what elevates your work into something more than anyone else's. Just take the time, take away everything that doesn't look like the ring you want it to be.